All right, folks, it's Bass Action, back in action here. In this video, we are going to get an understanding of how a 45-45-90 triangle works. We're going to look at some examples, and then we're also going to look at its extended ratio. That's going to be a 1, 1, and a radical 2, and we're going to learn how to use that extended ratio and where that extended ratio comes from. Okay, so this time what we're going to start with is not an equilateral triangle, but we're going to start with a square. So if we've got a square here, what we of course understand is that we would have 4 right angles. If these two sides are the same in a nice right triangle, then of course the two angles would also have to be the same, making this angle 45 degrees and this angle 45 degrees. So we can see that's where our triangle gets its name, 45, 45, and 90. Okay, so what we want to understand is where this extended ratio is coming from. Now, let's highlight our triangle so that we can draw our attention to this. So this is what we're going to focus on to get to that extended ratio. Similar to what we saw in the 30, 60, 90 video, if we look at the coefficient here on the x, there's that implied coefficient of a 1 and an implied coefficient of a 1 on both of those x's. These ones are the same ones over here. So the ones in our extended ratio are going to represent the legs. And this is going to be easier than our other triangle because both of the legs are the same. So what we want to understand is, where does this radical 2 come from? So just like before, we're going to look at our triangle and we're going to jump into our Pythagorean theorem. We're going to solve for the d here. So we're going to have an x squared plus an x squared equals our d squared. That of course is going to give us 2x squared equals d squared. Taking the square root of each side, that's going to get us to our square root of 2 times our x is our d. So we can replace that in our picture, radical 2 times an x, and sure enough, there is the radical 2 that we were looking for. So this is going to represent the hypotenuse in a 45-45-90 triangle. Now we're just going to look at 2 quick examples here. In our first example, we're going to notice again, it's a 45-45-90, because if this is 45 and this is 90, then the last angle also has to be 45. What we want to notice here is that you've been given the leg in this triangle. So this is going to be a leg. Of course, the 2 legs should be the same. So automatically you should be able to fill in that this is a 9 radical 6. And then we want to go ahead and look at our extended ratio and understand that we want to move from a leg to the hypotenuse. Well, of course, the hypotenuse should be bigger than the leg. So to go from the leg to the hypotenuse, we're going to multiply because we want to get bigger. We're going to take that value for the leg, and since we're getting bigger, we're going to look at, this is our factor of a radical 2, so we're going to multiply this by a radical 2. Now, of course, when we multiply that, that's going to give us a 9 radical 12, and we always need to remember to simplify our radicals. And of course, that square root of 12 is going to simplify, a 2 is going to pop out, and our final answer will be 18 radical 3. So we found those remaining sides. Now the next one we're going to look at, just one more quick example, is we've got this time a hypotenuse. So this is going to be the hypotenuse of our 45-45-90 triangle. Again, 45, this is 90, this one has to be 45. Again, this is going to be easier because of course we know that these 2 legs are going to be the same. So now we're going to go from our hypotenuse to our leg. So when we're thinking about our extended ratio, this time we're starting here and we're wanting to go backwards. So we're going from something that is big, we're trying to get smaller. We're going to work with this factor of 2. So we're going to take our 15, divide it by the radical 2. And of course, we have to remember to rationalize. Can't leave that radical in the denominator. Multiply top and bottom by that. So our legs, both of them, will be 15 radical 2 all over 2. It's important to note Do not convert this to a decimal. Do not convert this to a mixed number. Make sure that everything is either clearly in the numerator or clearly in the denominator. Do not let anything go floating around. We will do the remaining 2 questions in class. So for right now, just get comfortable with remembering that extended ratio.